Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris Farhan bin Asha, metric number 2010577. We are from Group H, and our community service project for this subject is EcoBin Notify Smart Recycling Bin. And let us move on to the first part, which is introduction. Recycling bins aid in environmental sustainability by streamlining collection operations and reduce unnecessary pickups and overflow incidents. Therefore, a proper planning and management of recycling bins is crucial to optimize the usage of recycling bins. From the statements, we have come up to one problem statement, which is poor management of full recycling bin around Kuliah for Engineering. For instance, when recycling bins become full, students tend to leave recyclable items next to the bins, leading to a clutter and visual pollution around the bins. This can make the area of the bins look unkempt and dirty and may discourage students from recycling. From the previous problem statement, we have come up with three different objectives. The first one is to ensure that there is an organized plan for handling waste that is placed in the recycling bin. Second is to improve the accessibility and convenience of recycling bins across Kuliah of Engineering to encourage students to recycle more frequent and correct. The third objective is to educate university students about the importance of recycling bins and the specific recycling guidelines. The automation flowchart below shows how our project works, and for your information, our project works just fine. According to our expected flowchart, our idea of our project is the sensor will be located on the top of the dustbin, where it will be detecting any waste coming through from students. Okay. And we also have sensor display that will be displaying whether the sensor is blocked or not. I'm pretty sure you will be questioning how does the sensor differentiate whether the blockage is only a single blockage or the blockage indicates that the bin is full. Okay, we have come up with one solution where it is indeed that whenever waste comes through, it will display yes on the sensor display. Therefore, we have set a period of 30 minutes time in which whenever the bin is full, it will be detecting the waste constantly without bleeping, without changing the sensor display, meaning that when the bin is full, the sensor will keep detecting the waste. Therefore, a 30 minutes period has been set by us, minimum, so that if the time exceeded the 30 minutes, it will alert the waste management team and Kuliah of Engineering authorities to indicate them that the dustbin is full and a cleaner can empty the bin. For planning and control, we have a few measures that will be taken in order to control our project flow. In the slides, we state the flow of our plan, where people will put the recycling material in the recycling bin, and then when the bin is full, the sensor that is located in the upper part of recycling bin will detect the level of the trash, and it will alert the management team to take action and manage the recycling bin and empty the bin. For control, we decided to keep monitoring our sensors on the recycling bin to ensure that our sensors works just fine, and also it will be functional to alert the management so that the cycle will be repeating smoothly.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hafiz, metric number 2016859, and I'll be explaining on the innovation side of our project. Okay, so our design philosophy is simple, right? We want our product to be very simple to install, very simple to use, very simple. It just works. The philosophy is just works, right? So we take the normal recycling bin and we simply attach our sender module on top of it to just convert it instantly into a smart recycling bin. That's our design principle here. Simple to use and make it easy. So for our project prototypes, there are two parts for it to work properly. So the EcoBin Notify requires two parts, which is the sender module and the receiver module. The sender module basically uh, tells the receiver module if the trash bin is full or not, right? We'll get into more detail on how the sender module works, but let's talk about the receiver first. So the receiver is powered by two AA batteries and one microbit module, right? And then it receives its information from the sender module via radio. It will flash red on all of its LEDs when the bin is full. That's the role of the receiver module. So on to the next. So this is the sender module, the more important module. It comprises of one microbit module and one electromagnetic proximity sensor, right? Uh, how it's connected is fairly simple. The microbit uses pogo pins on the side of the board itself, right, to be simply connected with the electromagnetic proximity sensor. So the pogo pin 0 is connected to the output of the sensor, and the pogo pin 3 volt is connected to the VCC on the sensor, and the ground is connected to the ground on the sensor as well. So that's how it is set up on the sender module. So we move on to the next. So this is how it works in full detail, in full clarity. So when there is no obstruction on the front of the sender module, it displays an N, which means no, and it transmits no signal through radio, right? But when there is an object, or in this case, trash here, in front of the sender's sensor, it will change to Y, which means yes, there's something obstructing the top of the trash can. So this means it's full. It will then, via radio, send a signal to the sender module, and it will flash red, as you can see here. So this is how the project works. Our EcoBin notify will notify the sender module when the trash can, or in this case right here, the sensor of the sender module is obstructed. Then the receiver module flashes a bright red.
My name is Muhammad Nakib bin Muhammad Nasir with metric number 2014313. Next, I will explain about post-project review. As far we can see, the objective of the project are achieved successfully, which are improving the waste management efficiency and reducing contamination. Besides, we also get positive feedbacks from the people that use the smart recycling bin. Hence, it can promote effectiveness in promoting recycling behavior among students. At the end of our project, we have done short survey to gather feedbacks from the consumers of our smart recycling bin. Total respondents of our survey is 20 people. Overall, 90 people agree that the idea of smart recycling bin is a good contribution to waste management efforts. But for the design of the bin, we got variety of responses, and some agree that our design is still have many aspects that need to be improved. For sure, there are many risks and issues from this project that we have identified. First, vandalism and theft. Smart recycling bins installed in public areas are vulnerable to vandalism, theft, or damage, which could disrupt their operation and functionality. Next, sensor malfunction. The sensors in smart recycling bins may malfunction due to technical issues, especially when the sensor is very far from the receiver. Lastly, weather conditions. Exposure to extreme weather conditions such as rain or high temperatures may affect the performance and durability of the smart recycling bins. To overcome the issues, we have come up with some ideas and recommendations that may be useful for future that can be used for improvement. In response to the identified risk of vandalism, theft, and exposure to environmental factors such as rain, it is recommended to provide the sensor with a special protective case. This case should be designed to shield the sensor from external elements such as water and physical tampering, while still allowing for accurate data collection and functionality. To address the risk of interference with sensor functionality, it is essential to keep the area around the smart recycling bin clear of obstruction. Regular maintenance activities such as monitoring of potential obstruction should be conducted to uphold clear sightlines and maximize sensor performance. I think that's all from us. Thank you.